10, 13, 14, and 15, we're doing a two-way independent sample ANOVA test. Pomeroy Restaurants is examining the satisfaction of its customers. The restaurant chain is looking at two possible influences on customer satisfaction. Restaurant location, North Valley, West Hills, River Glen, or Hillview, and the type of meal, lunch, or dinner. At each of the 4 locations, a random sample of 10 lunch customers and a random sample of 10 dinner customers were chosen. Each customer sample was asked to rate his satisfaction with the meal on a scale of 1 to 10. The mean satisfaction rating for each of the 8 groups were computed and are shown in the graph below. So here we have North Valley, West Hills, River Glen, and Hillview, and then dinner and lunch, dinner being the blue line, red being the lunch line. After checking that the assumptions for the test were satisfied, Analysis for Pomeroy Restaurants performed a two-way ANOVA test. The dependent variable was customer satisfaction rating, and the factors were meal and location. The partially filled ANOVA table is shown below. Complete the table and answer the questions after the table. Do not round any values in the table except the F statistic value. You should round to at least 3 decimal places for the F statistic value. Again, I'm going to go ahead and move this, really jumped, so that we can see what the table looks like. We don't really need the graph. It's there for fun, but we don't really need the graph. So, on here, the degree of freedom is going to be the number of samples, or the number of locations, I should say, the number of, in this case, locations, since I'm doing locations, minus 1. In this case, we have 1, 2, 3, 4 locations, so we're going to do 4 minus 1, which is 3. For our meals, they already figured out our degree of freedom, but in that case, we had 2 different meals, 2 minus 1, 2 minus 1. 2 minus 1 was 1, and that's where that number came from. They already put that in your table for you. So for the number of interactions, you are going to take the degree of freedoms from the first thing times the degree of freedoms from the second. So in this case, we're going to do 1 times 3. 1 times 3 is 3, and so 3 is going to go in there for your interactions. All right. The mean of the squares, just like before when we did the mean of the squares, we are going to do the sum of the squares. Sum of squares divided by its degree of freedom. So in this case, they took 0.8 divided by 1 and got 0.8. On this one, we're going to take 8.1 and divide it by 3. So if you take 8.1 and you divide it by 3, you should come up with 2.7. On the next one, we're going to take 15.9 divided by 3. 15.9 divided by 3, if you divide that out, you get 5.3. For my F statistic, you are taking the mean of the square error divided by, the mean of the square divided by the error. That's what I was doing. So for my F statistic, the mean of the square divided by the error. So for this box here, they took the 0.8 divided by the 1.163 to get the 0.688. For this box here, we are going to take the 2.7 divided by the 1.163. So the mean of the square divided by the error number. So if you take 2.7 divided by my 1.163, we get 2.322. 2.322. That one they said to go 3 decimal places. 2.322. And then on this one here, we're going to take our mean of square 5.3 divided by the error 1.163. If you take your 5.3 divided by your 1.163, you get 4.557. So 4.557 goes in that box. All right. So, degree of freedom, I take the number of items I have from the table minus 1. So the meals, we had 2 meals, 2 minus 1 is 1. Locations, we had 4 locations, 4 minus 1 was 3. The interactions, we're going to multiply those two numbers together. 1 times 3 is 3. Over here for your mean of squares, you take the sum of the squares divided by the degree of freedom in that row. So here they took the 0.8 divided by 1 to get 0.8. We took 8.1 divided by 3 to get 2.7. We take 15.9 divided by 3 to get our 5.3. On the end, for our F statistic, we are going to take the mean of the square divided by the error. So on the top one, they would have taken 0.8 divided by 1.163 to get the 0.688. Then we did the 2.7 divided by the 1.163, which is our 2.322. And lastly, we did the 5.3 divided by the 1.163, which is our 4.557. So filling out that table. The question says, what is the p-value for the test for an interaction between these two factors? So again, we are going to find our p-value. So we're going to do p of f is greater than. And then we want it for the interaction. Here's the interaction. And so we have to use the F statistic for the interaction. If it said meal, we would have used the one for the meal. Location, we would have used the one for the location. It wants to know the one for the interaction, so we're going to use 4.557. The degree of freedom for the numerator will be the degree of freedom for my interaction. The degree of freedom for my denominator is going to be the error. So in this case, the degree of freedom for my numerator, because we're doing interaction, is that number. The degree of freedom in the denominator is always the one with the error. So in that case, 72. So you're going to do P of F is greater than 4.557, since that's the F statistic for the interaction. Degree of freedom for the numerator is the degree of freedom for the interaction. The degree of freedom for the denominator is the degree of freedom on our error. When you calculate that out, you should come up with 0.006. So, again, I am checking my p-value, 0.006 compared to my level of significance. At a 5% level of significance, can the analysis conclude that there is an interaction? So, 0.05 is my level of significance. This is less, right, than that. So, on this case, since it's a less than, we are going to reject the null. In this case, for the null, we are going to say that there is no interaction. For the alternative, there is an interaction. So in this case, we are rejecting the null. So we are saying this is not true, so this is true. There is an interaction. So, at a 5% level of significance, can we conclude there is an interaction? Yes. Because we rejected the null, we have to accept the alternative hypothesis, which there is an interaction. If your answer is no, answer the following question. Where our answer was yes, so we don't have to answer the following question. We can just skip that. So, only answer it if you get an answer of no. Since we got an answer of yes, we can just go on. Number 14, a major television network is considering 3 potential situation comedies: Bobby's Brunch, My Ex-Husbands, and I Like Larry. A pilot first episode for each has been taped. The network is trying to determine whether some shows are better liked than others, and whether younger viewers under age 40 tend to have different opinions than older viewers age 40 and above. The network randomly selected 30 people under age 40 and 30 people age 40 and above. It is randomly divided under those under age 40 into groups of 10 and assigned a different show to each group. The network did the same for those age 40 and above. Each person watched the pilot episode of his assigned show and rated it on a scale of 0 to 20. After the network computed the group mean rating for each of the 6 groups, the group means are shown in the graph below. So they did the graph for Bobby's Brunch, My Ex-Husband, and I Like Larry. After checking the assumptions for the tests were satisfied, the network performed a 2-way ANOVA test. The dependent variable was pilot episode rating, and the factors were viewer age and show. The partially filled ANOVA table is shown below. Complete the table and answer the questions after the table. Do not round any values in the table except the F statistic value, which you should round to at least 3 decimal places. So again, I'm going to move this up so we can see our questions. So here again, we're going to take our number from our table, the number of groups, I'm going to call it minus 1. Viewer age. We have 2 different viewer ages, so 2 minus 1 is going to be 1. Just to show you for the shows, we had 3 different shows. 3 minus 1 was 2, and that's how they got that answer. For the interaction, we're going to take this one times this one. So 1 times 2 is 2, and that's how we got this number here. So, how many viewer ages? We had 2 groups minus 1, which is 1. How many shows? We had 3 shows minus 1, which is 2. We then multiply those 2 numbers to get that number from the table. Mean of the square. We're taking the sum of the square divided by the degree of freedom. So on this one, we're going to take 0.07 divided by 1, which of course gives me the 0.07. On this one, we would take the 2.53 divided by 2. 2.53 divided by 2 is our 1.265 they already have there for us. On the next one, we're going to take our 3.33 divided by 2. The sum of the squares divided by the degree of freedom. 3.33 divided by 2 is 1.665. 1.665 should be the number that I get when I take our 3.33 divided by 2. Then for the value of our F statistics, we're going to take the mean square divided by the error number. So for this one here, our mean square is 0.07 divided by the error, 2.523. So you're going to take your 0.07 divided by 2.523, which is 0.028. 0.028. On this one, we would have taken the 1.265 divided by the 2.523, and they got 0.501. They already did that calculation for us. On the last one, we're going to take our 1.665 that we got for our mean of our square, divided by the 2.523, which is our error. So 1.665 divided by 2.523 should be 0.660. 0.660. Once we have our table all filled in, we can answer our question. This one says, at the 0.05 level of significance, what is the critical value? We're going to do the critical value instead of the p-value. So for our critical value, we are going to do f sub 0.05, since we're doing the 0.05 level of significance, for an interaction between the two factors. So again, this is for the interaction. So for the interaction, this is my degree of freedom for my numerator. This is my degree of freedom for my denominator. So for my degree of freedom in my numerator, I had a 2. Degree of freedom in my denominator, I have 54. So I'm going to do f sub 0.05. Degree of freedom in my numerator is 2. Degree of freedom in my denominator is 54. When I calculate that out, I should get 3.168. So, on this one, we are doing that critical value. So, our critical value is 3.168. Our null is over here. Our alternate one is over here. This is no interaction. This is that there is an interaction. We are going to check our test statistic. It says, can we conclude there is an interaction? So if there is an interaction, we are going to use our F statistic up there, which isn't very big. Our test value is 0.660. Would that be less than the 3.168 or greater than the 3.168? In this case, it's going to fall in the section for the null. So if it's in the section of the null, we're going to say there is no interaction. Can we conclude there is an interaction? No, we cannot. Since we answered no, if your response is no, answer the following. At a 0.5 level significance, for which factors can the TV network conclude there is a significant test? So what we're going to have to do now is find our F statistic or critical value for each of these two factors. So for the viewer's age, we're going to do F of 0.05. My degree of freedom in my numerator is going to be the 1. My degree of freedom in my denominator is still the 54. So here I have to use the degree of freedom from whatever thing I'm checking, in this case my viewer's age. I was trying to see where I wrote that answer down at. So in this case, F sub 0.05, degree of freedom in my numerator, which was 1, my degree of freedom in my denominator, which is 54, gives you a value of 4.02. I'm going to compare that then on my F statistic for my test value. Again, if my critical value is 4.02 and my test value is 0.028, that test value is going to fall being in the smaller area. Yep, in the smaller area. So in this case, we're going to say, nope, there's no interaction there. Now I'm not done yet because I tested the viewer age. Now I have to test the show. To test the show, I am going to do F sub 0.05. The degree of freedom in my numerator would be the degree of freedom for the show, which in this case is 2. And then the degree of freedom in my denominator is my error again, 54. And then I'm going to calculate that value. Well, that happens to be the same thing I did when there was an interaction because my degree of freedom was the same number. So I should get that same value, 3.168. On this one, when I'm doing my comparison, I ran out of room. I'm going to put it up here. 3.168. Here's my null. Here's my alternate. I'm looking at this test statistic. So 0.501. Again, that's going to be less than the 3.168. So we're going to say there's no interaction. So on this one, there wasn't an interaction from the viewer's age. There isn't an interaction from the show. So we're going to check neither in this case. So when we do this, we're going to do our critical values for the degree of freedom from the viewer age, the degree of freedom from the show. We're going to compare those using our F statistic for each of those separately and see, does it fall in the null, which is no interaction, or does it fall in the alternate one, which means there is an interaction. All right. Number 15 will be our last one here, if I can find number 15. So on number 15, a psychologist is interested in people's views on various crimes. She has produced videotaped reenactments of 2 different nonviolent crimes, jewelry theft and credit card fraud, and has asked viewers to give the length of the prison sentences in months the perpetrator should get as punishment. The psychologist is looking at differences in the perceived seriousness of the crimes and also at whether there is an influence of the viewer's self-reported political position as conservative or liberal. She randomly selects 20 conservatives and 20 liberals. She divides the conservatives at random into 2 groups of 10 for each crime. She has a different group of conservatives watch the reenactment, as she did the same for liberals. After collecting the participants' prison sentences judgments, she computed the group mean judgment for each of the 4 groups. These means are shown in the graph below. So we got our graph. We've got 2 here, 2 here. I'm going to slide that up a little bit. So we need to fill in our table. So again, for the degree of freedom for each of these separately, we're taking our number of groups minus 1. Here we have 2 groups, 2 minus 1 is 1. That's how we got this answer. Here we also have 2 groups, 2 minus 1 is 1, so this is going to be 1. So in both cases we have 2 groups and 2 minus 1 is 1, so the degree of freedom here is 1, the degree of freedom there is 1. Our interaction, we're going to take the 2 degrees of freedom and multiply them together, so 1 times 1 going to still give me 1. For the mean of squares, again, we're taking the sum of squares over each degree of freedom, which in this case will be easy because they're all over 1. 72.9 divided by 1 is 72.9. 3.6 divided by 1 is going to give us 3.6. 8.1 divided by 1 gives us 8.1. We wish they were all that easy. We just have to divide all those by 1 since all of their degrees of freedom is 1. Our F statistic, the mean of the squares divided by the error number. So in this case, they would have taken the 72.9 divided by the 8.36. On this one, 3.6 divided by 8.36. On this one, 8.1 divided by 8.36. So again, we're going to do those 2 calculations. 3.6 divided by 8.36 should give you 0.431. 8.1 divided by 8.36 should give you 0.969. So what is the p-value for the test for the interaction? So I want to do my p-value. I am going to do p of f is greater than, and since I'm doing the interaction, I'm using the f statistic, which was this one right here, 0.969. My degree of freedom in my numerator would be the degree of freedom for the interaction, which is 1. My degree of freedom in my denominator is my degree of freedom for my error, which is 36. So p is greater than 0.969, degree of freedom in the numerator 1, in the denominator is 36. I might have those backwards, but the 1 and the 36 are in the right spots, whichever the label of my boxes are there. Either that or I wrote it on my paper backwards, which I could have. And so I should come up with 0.331. 0.331. So we are going to then test this. Since we are doing our p-value, we are going to compare that to a 0.5 level of significance. 0.331 compared to 0.05. 0.331 is going to be greater than 0.05, so we are going to accept the null that there is no interaction or no difference. So, can we conclude that there is an interaction? No, we can't conclude there is an interaction. If our answer is no, then we have to test each thing separately. So in this case, we are just going to go ahead again and just test the critical value, even though we did the p-value here. We're going to do the critical value like we did on the previous problem. So, for the first one, we are going to do f sub 0.05. Degree of freedom in my numerator would be my political position, which is 1. Degree of freedom in my denominator, going to be my error, 36. So if I calculate that out, we are going to come up with 4.11. Testing, 4.11. Here's my null, here's my alternative. I'm going to look at my p-value. My f statistic is 8.720. Well, my 8.720 is in the H1 section. So there is a difference here. Yes, there is a difference. Before I check my answer, I've got to check my other part. On my other part, I'm doing the type of crime. For the type of crime, we are going to do f sub 0.05. The degree of freedom in my numerator, again, is going to be the 1 for type of crime. If those numbers were different, I'd have to be careful, but it's the type of crime degree of freedom, so it's going to be 1. The degree of freedom in my denominator, going to be my 36. And so since those two things, they look the same because my degree of freedom for both of these were the same, I'm going to get the same number. So I should get my 4.11. However, I have to use the F statistic that I got for type of crime. The F statistic for type of crime was 0.431. 0.431 would fall in this first section in the null where we said no, there is not a difference. So we found there was a difference in the political position, but not in the type of crime. We're just going to check, oh, there's a difference there in the political position when I do my test. So if I get a no here, I'm going to find my critical values for each of these separately, making sure the degree of freedom in the numerator is the degree of freedom for each of those two things separately. And then I'm going to compare them to the F statistic for each of those separately.